Hello friends, welcome back. As part of 8th grade syllabus factorization of algebraic expressions, let's try to understand splitting the middle term and do some examples based on that. So let's have a look at this example. We have been asked to factorize x square minus 49x plus 600. So before going ahead with this example, let me just try to recap what we know about splitting the middle terms. Now, the idea of splitting the middle terms is you want to factorize them, you should have even number of terms, so that here you should have 4 terms so that you can take common factors. Now you have only 3 terms, so you want to make them as 4 terms. That is nothing but splitting the middle term. If you observe, this is the middle term, ax square plus bx plus c, ax square plus bx plus c. You want to split the middle term bx into 2 n1x and n2x, such that you can take the factors, common factors, and you can find out the factors of ax square plus bx plus c at the end. Now how we can do that? We can do that by leveraging, saying that the sum of those two numbers should be n1 plus n2 and the product of the numbers should be equal to is n1 and n2. Sum should be equal to b, because you are splitting b into 2 parts. So if you add them up, it should be again back to b. Not only that, when you multiply them, it should be equal to c into a. So this is how we have to find out the factors. These are the conditions. So sum should be equal to n1 plus m2 equal to b, product equal to n1 into n2. That's nothing but equal to c into a. Now with that understanding, what are the different types of conditions we have here? Let us have a look at that. Now what can be the scenario? The scenario can be the product can be positive or the product can be negative. So first I will take product is positive. If the product is positive, then we know that if product is positive, then I know that n1 n2 will have same sign, either plus or minus. n1 n2 will have same sign, either plus or minus, and equal to the sign of b. If the b is having positive sign, n1 n2 also will have positive sign. If n1 n2 or b is having negative sign, n1 and n2 also will have negative signs. Next case is the product is negative. So you remember, whenever the product is positive, you have to add 2 numbers to get your b. You have to literally add 2 numbers. If the product is negative, n1 n2 are either plus and minus or minus and plus. They are opposite sign. n1 n2 are opposite sign. In the case where the product is positive, they are of the same sign. And here, since they are plus and minus, you are looking for subtraction of 2 numbers so that you can find the value of b. So if it is product is positive, you are looking for n1 plus n2. If the product is negative, you are looking for 2 numbers whose difference is nothing but equal to b. So with that logic, let's try to solve this problem. So ax square plus bx plus c, if I write it as ax square plus bx plus c, I will see that a equal to 1, b equal to minus 49 and c equal to 600. Now you want to split 49x minus 49x into 2 parts. You can see that the product is nothing but equal to c into a, that's equal to 600, and the sum is equal to b, that's equal to minus 49. So I have to divide 600 into 2 factors such that when I sum them up, I get minus 49 and when I multiply I should get 600. Now what is the logic we know? We have to first look into product. If product is positive, is the product positive? Yes, the product is positive. So we go to that criteria. Product is 600 now, which is positive. If product is positive, then we know N1, N2 will have same sign as that of B. What is B? Minus 49. So both of them have negative signs. Not only that, we are saying that your product is positive but the sum is negative. That means you have to add two numbers. So which numbers we have to add? For that we have to find out the factors of 600. So let me just try to keep here the factors of 600. You can do that by prime factorization. I'll just do that this way. 1, 2, 3, 4, 5, 6, 10, 12, then let us say 15, I have 20, then I have 24, then I have 25, then I have 30, then I have 40, then I have 50, you have lot, 100, 150, 200. Okay, now I will not go there. Can you tell me why I don't need to go further? I can actually stop at 50 itself. Why? Because these all are useless now. Because you are saying you have to add two numbers to get 49. You have to add two numbers to get 49. Now look for the combinations where you can get 49 out of this. 15, 30, no. 20, 24, no. 24, 40, 40 and 9 I don't have. Yeah, but I see 24 and 25. 24 plus 25 is 49. 24 into 25 is 600. So can I take them as minus 24, minus 25. So this logic you have to understand. Since we are saying you have to add two numbers to get 49, any factors above 49 are not interested to me because they will not help me in the solution. So if now you can actually reduce the number of choices you have, and you see that 24 and 25 makes it. So what will be my next step then? Next step will be x square. 49 I know now how I have to write, that is minus 24 and minus 25. So I'll put it as minus 24x minus 25x plus 600. Now in x square minus 24x minus 25x plus 600, I will write one more step just for your understanding, that is x into x minus 24 into x minus 25 into x. Can I write 600 as multiples of 25? Yes, we know that is 25 into 24. Just now we have seen that. Now let's take common here. Factors. We see that x is common factor here and we have 25 common here. So I'll write down x into x minus 24 minus, if I take minus 25 out, I will have x minus 24. I hope you are okay with that. If you want, actually you can write it as plus 25 into 24 minus x, and you can again change it in the next statement. But I see here in the common factor I have x minus 24. So I should get here also x minus 24. If I take plus 25 out, I will have minus x. Again I have to multiply. So I have taken minus out. This is nothing but equal to x minus 24 into x minus 25. So factorization of x square minus 49x plus 600 is x minus 24 into x minus 25. So we'll do some more examples. to understand better about splitting the middle terms. Maybe around 6 to 7 examples we will do. This is the first example of the set. I'll catch you again with one more example. Thank you. Thanks for your time.